Good morning, everyone. Welcome to the Build 2018. My name is Bhanu Prakash, and I am a Senior Program Manager at Microsoft working on Azure Databricks. And with me, I have Maddie.
Hey, everyone. Good morning. I'm Maddie Schulz. I'm Product Manager at Databricks and leading the Azure Databricks product.
Thank you, Maddie. So today, we are going to talk about data science experience with Azure Databricks. So before we get started, can you quickly show how many of you here have worked on Spark? So maybe 10%. And how many of you have worked on Databricks or Azure Databricks? So 3 or 4. So thanks for the info. This will give good context as we go through the presentation, give an intro about Databricks, and then talk about the products and some of the capabilities, and talk about the data science experience with Azure Databricks. So let's start with the big picture. If you think about any advanced analytics or big data pipeline, this is a generic framework. You start with data collection from different data sources, and these could be your business apps, your IoT devices, sensors, or your custom apps, and so on. And you would end up using any of the technologies to ingest the data. So you would use Azure Data Factory for ingestion, whether it's from on-premises or 70+ data sources, or you would use Kafka with HD Insight, IoT Hub, Event Hub for real-time and streaming data. Once your data is ingested, then you land it up in Azure Storage, and then you would prep and transform the data. As part of prep and transform, this is where you use Azure Databricks, which I'm going to talk about in a bit. And then you would put the transformed data back in a serving layer, which could be Azure SQL DB, Azure SQL Data Warehouse, or Cosmos DB, and then use it to do ad hoc visualization, analysis, and query on top of your visualization layer. And again, this is a very generic framework, and depending on your use case and scenario, if it is structured streaming, or if it is data warehousing, or if it is ETL, you would tune it based on your need. Now, what is Azure Databricks? So Databricks is a company that invented Spark. It is the company that actually created Spark a few years ago based out of a project at UC Berkeley. And in fact, more than 75% of the code contribution is done through Databricks. So Microsoft as a company partnered with Databricks to create this managed Spark offering on Azure. So it is basically the best of both worlds. So when you compare of Spark with open source Spark with Databricks runtime of Spark, it is based on top of that, but Databricks as a company has added proprietary code on top of Apache Spark, and which is the reason that it is optimized for performance, optimized for data science and data engineer and analyst scenarios. In fact, it is optimized for cloud as well. And then secondly, with Azure, you get all the scale, you get the performance, you get the security, you get the compliance. And when we partnered, we made sure that it stands on all the 3 pillars, which is productivity of a data scientist, performance, scalability, and security that an enterprise customer would need. So as a result of that, what we have today, when we went GA of the service last 2 months back, we have got the productivity where you can do a single-click deployment of your Spark environment with Azure Databricks. Secondly, you get the scalability in the sense that wherever Azure is present, we are available today in 11 regions, and we are expanding very aggressively. So you are able to use Azure Databricks and in the regions that Azure is available. And then thirdly, you get the security that comes as part of the Azure offering. So if you look about as a first-party service, what I mean by that is that it has integration with all the first-party services that is available in Azure. To give you an example, the integration with Azure Active Directory. And in the demo that I will show you, you would be able to use your own corporate credentials to access and log into your notebooks to run jobs. What could be better than that? Like, you don't have to worry about creating users, or you don't have to worry about setting up your identity provider. It just because of the fact that it is natively integrated with Azure Active Directory, you can access or run jobs by just authenticating using Azure Active Directory. Secondly, for streaming scenarios, it has integration with Kafka using open source Kafka connectors. So you can have SD Insight Kafka cluster created where you would stream the data, and then you would do structured streaming using Azure Databricks. Then at the same time, we have got native connectors for Event Hub and IoT Hub. So you can end up using those native connectors for your streaming scenarios. We also have got connectors with Azure Data Factory, which means you can create an ETL pipeline which can spin up a notebook activity through Azure Data Factory, and then that job will run on your compute cluster on Azure Databricks. And then for storage, you could use, because it's a decoupled architecture where your compute and storage is separate, you would use Azure Blob Storage for storing your data and doing the compute on Azure Databricks. And then lastly, as we are seeing need and as we are hearing from customer feedback, we are making sure that the native experience that comes as part of a first-party service is built in. So Power BI, for example, we have got native integration with Power BI where user would go ahead and open up Power BI dashboard, and that can just read and write, that can just read the data and query data from Databricks. And at the same time, for structured and unstructured analysis, you can do read and write from Cosmos DB and Azure SQL Data Warehouse. So let's talk about data science. What is a typical journey of a data science? What do data scientists care about? And then what are some of the challenges and how Azure Databricks solves those challenges? A typical data scientist projects, if you start with, there is a data exploration. You want to understand what is the business problem you are trying to solve. As a data scientist, you want to query what kind of data do you have and what is the meaning that you want to get out of by exploring this data. Once you have an idea of the data, then you want to do some feature engineering. You want to do some analysis on the data to understand, is it giving me the right set of results? And as part of that, you would want to do ad hoc queries. You want to do some modeling, and you want to do create models on top of that. For example, if your scenario is machine learning, you would end up creating ML models on your after your feature engineering. And next, once you have done some analysis, you would communicate the results with your stakeholders, and as part of that, you would end up sharing the results to the different stakeholders in the company. So as a part of doing this journey of analyzing the data, creating models, you want to do it at a rapid rate. So as a data scientist, you want to iterate very quickly on the data. You want to make changes, and you want to see what the results are, and you don't want to worry about managing the infrastructure behind the scenes. You just care about your data, and we want to make sure with Databricks that experience is smooth. Then you want to visualize the data through different dashboards, whether it's the first party or a third party dashboard. And at the same time, it's not a one-man army, so you are a team of data scientists. You collaborate with different stakeholders in the company, with business analysts, with VP of sales to come up with some decisions. And as part of that, you want to share the results of the queries with your colleagues in your company. And then as part of that, you share it in a manner that has role-based access control in order to make sure, like, not everyone has access to all the data, because there are some sensitive data, and you want to make sure that sensitive data is not shown to the person who is not authorized to. So all these things, there are certain challenges that data scientists come across. And those challenges are, hey, I don't want to care about my infrastructure. I don't want to configure the VMs. I don't want to be in the business of installing the software. I don't want to be in the business of making sure that my VMs are up and running. Then the second, you don't want to be in the business of, you want to operationalize it, and you want to make sure that once I have done some analysis, I can put it in some pipeline or some operational model where the analysis happens in a repeatable manner for the incoming new data sets, right? And you want to get the value very quickly. So all these in different form factors, in different ways, are challenges that data scientists have been facing. So this is what Azure Databricks brings to the table. And as I mentioned, there are 3 pillars. One is productivity. So Databricks as a runtime itself has optimized performance through things like DBIO caching or inbuilt caching, where it uses the in-memory technology to do processing of the data very fastly. Then it's based on Apache Spark, so your existing code, whether you have written in Scala, Java, Python, R, or Spark SQL, would run to it. So as a developer, you have plethora of languages support. There is a serverless form factor where you don't have to worry about the runtime. It automatically configures the runtime, which is stable based on your workload, and you would end up just creating the cluster as a single-click deployment. And thirdly, you can program using the REST APIs that are available in an automated manner. The second thing is about the operationalization. So I talked about Azure Data Factory, where you can operationalize your notebook or your jobs, schedule your notebook, get notification. And tomorrow we have a session on ETL and data warehousing where we'll go in deep about this. And then lastly, it also is something that different personas could use it. So it could be data scientists for doing ad hoc analysis. It could be data engineers to do ETLs and ELTs. And it could be business analysts to view the dashboards and make meanings out of the data. So let's go through a quick demo and try to see what are the capabilities that comes and how easy it is to use to make meaning out of your data using Azure Databricks. So this is my Azure portal, and I signed in. So I go ahead and click on Azure Databricks and click on Add. And here I would select a subscription and give a workspace name, create a resource group, select the region, and then select SKU, and just go ahead and create it. Now, once this workspace is created, it is supposed to be shared by teams. So one of the things that I mentioned about is easy collaboration and collaboration in a manner that it has authorization associated with it. So once this workspace is created, I go ahead and initialize this workspace and click on Launch. Now, because of the fact that it has native integration with Azure Active Directory, it will just single sign me on to the Azure Databricks workspace without even requiring me to sign me on. So this is one example of a productivity where your InfoSec team in your company need to worry about, hey, how is the authentication happening? Because it is given to Azure Active Directory, and AAD is taking care of authenticating the users. Now you go ahead and select your workspace. So I select this. And this is the home page that you will come, where you will have some intro materials, your recently opened notebooks, and so on. Now, if you hover to the right, you see an account, and then click on Admin Console. And as I was talking about sharing, I can go ahead and invite a user who is in my org to have access to my workspace. So I can say, and then click on OK. So this user will get added to my workspace, and then basically I can give, whether I decide to give admin rights or give the user the permission to create the cluster and so on, right? Then let's start with the cluster, which is where your compute will be running up on, and this is where the Databricks runtime will be running, right? So I go ahead and click on Create Cluster. And as I was talking about, this is a single-click deployment. So you just have to give your cluster name. And then there's a default runtime that's already selected. And if you scroll down, you see this min and max worker. What this means is when you enable auto-scaling, you literally pay as you use. So it is not when you enable auto-scaling based on your payload, based on the jobs that are running on the cluster will scale up or scale down. So if your data scientists are running jobs during the daytime, it can scale up to the max allowed. And then at nighttime, when no one is running any jobs, it can just shrink down to the minimum worker node that you have given. And beyond that, you also have the option to set auto terminate, which is enabled by default, which means that if there is no activity on the cluster and the cluster is idle, it will just terminate after that X amount of time. And when we talk to the data scientists and our customers, what we found that this helps in saving cost, because in this way, you are literally paying for what you use. In addition to that, the cluster create is pretty fast. It takes around 5 to 7 minutes, which we are further optimizing to create it even faster. So once you create it, then what you see here, so I go ahead and go to a particular cluster, and I can go ahead and edit the cluster, and I can change the VM type. So for example, I started with a DS to V3. I can go ahead and change to a L series, and then I can restart a cluster, which can restart in a minute, and then I can use that VM type. Or I can say, hey, I want to attach a tag for my internal chargeback. So I, as an admin of this environment, because who has created the cluster, I want to make sure that I have chargeback for my internal teams, and you can create tags. And then you can enable logging based on where you want to make sure the logs of the analyst logs go to, so you can configure that. And then you can also put permissions in terms of who has access to attach a cluster to a notebook, or restart a cluster, or manage a cluster. So I go ahead and give my colleague Anand access to, let's say, restart this cluster. So when he logs in, he will have permission to restart the cluster, right? Then secondly, what you see here in the cluster, there is something called serverless pool. This goes even one level further, where you don't have to even worry about selecting the DB runtime, where it automatically configures based on the stable version that is available per your scenario. And you can, it also provides the fact that if there are multiple users running jobs on this serverless pool, it guarantees user level isolation to a degree that it has fault tolerance built in. And at the same time, if any user hogs up the resources, this will serverless pool will make sure that there is guarantee of resources available to the different users who are accessing the cluster resources for running jobs. So I have this cluster, then I go ahead to the jobs, and I can create a job. So this is something that I was talking about, your thing that you can schedule and you can do a nightly job. So here I can select a notebook or a jar or configure Spark Summit. And let's say I go ahead and select this notebook. And then once I select it, I can schedule this notebook to run, let's say, every hour or every day. And then I can go further to be notified for any, for when the job started or when the job failed, or when the job succeeded, and so on. Then I can put some retries, I can put some timeouts. So these are the things which are built-in capabilities that you as a data scientist or data engineer do not need to worry about, because when you want to automate these tasks, you want to make sure you are alerted, you are notified, or there is a retry logic that is already built in that you don't have to worry about while writing your custom code. And in fact, you can share it with your colleague who can even go ahead and manage the run. For example, if you are going on leave or something, and then you can have option to run it now, or you can run it based on the schedule. So what it will do is, it will go ahead and create a cluster within a matter of few minutes. It will run the job, which is on the notebook. And once the job is completed, it will just terminate the cluster. So this is another example where it is very easy for a data scientist to run the job on a regular schedule. Now, I talked about cluster. This is the data part which comes. So you can create a table and you can give the schema for the data, so that when you visualize, the meta store is already defined, and that can be used across clusters, right? So I can go ahead and say add a table, and then I can browse. And let's say I browse this and then create a table with this data. And then here I can provide the schema as well. So it will read the schema, and then I can create a table based with providing like what kind of delimiter it has and so on, and then I can just go ahead and create it, right? The next thing I want to talk about is the workspace and how to use the notebook. So if you go to the workspace, you can organize your workspace in the directories. So, and you can give permissions at each level. So I can go ahead as an admin and I can give permission to the user who has also who can have admin level permissions to my workspace. So I can select the user and say, okay, give this user manage permission, and then done. And then I can go ahead and create another folder here in my user directory and say, let's say sales, and go ahead and I created a folder. And then I can go ahead and let's say Maddie exported a notebook in a DBC archive that she wrote, and I can import that notebook in my workspace. So I go ahead and say import, and I choose the URL, and then go ahead and click on import. So as you see, like it's pretty easy to share as through import and export, but Databricks has gone one step further where you can directly share the notebook with your colleagues. So I can go ahead and provide permissions to the users that I added in the admin console and say, okay, share it with this user, and this user, by the way, can just read the notebook and does not have permission to run any jobs, right? So this user can just run the notebook, and then we come to this notebook section. So one of the things that we mentioned, we talked about as part of the challenges that data scientists see is iterate. They want to iterate rapidly. They want to make meaning out of the data very quickly, and they want to have interactive analysis as part of this experience. So this is a proprietary notebook from Databricks where this notebook, if you see, is a SQL notebook. However, there is this magic command %Scala where you can go ahead and run Scala, or you can go ahead and run Python, or you can go ahead and run Spark SQL. So let's go ahead and attach a notebook, attach a cluster to this notebook for it to run. Then let's go ahead. So we imported a table employee that we created, and let's go ahead and run this, right? So you see how quickly it gave the result, and now you can go ahead and visualize this based on the chart. So you can create a bar chart, or you can go ahead and create a map chart, or you can go ahead and create a line chart, or basically whatever options that are available. And you can even choose like whether you want to view the sum, the count, and so on, right? So let's go ahead and run this query to see the count of number of employees who got more than 280K and across different states. So I run this, and then I get the result. And then I go to my comment section, and I can have option to add a comment. So other thing is in terms of revision history. So if I, as a data scientist, made changes to my notebook, I can go back to the previous version, and then I can just restore this notebook to the previous version, right? And then it will basically restore to the version that was originally there. Or I can, if I go back here, you see the option Git not linked. So I can go ahead and even link up my GitHub account, so I can commit changes to my GitHub repository. So just to give you an example, I can come to my GitHub, and then I go to my settings, and then generate a personal access token. And give permissions for my repo. So generate token, and then I can just link this repo to my Databricks workspace. So I go ahead and Before I have to do that, I have to, okay, so I had already created a personal access token. So I just synced it, and then I go ahead and click save. So now if I go back here, if you see this option, it says git synced. So basically, whenever I can commit the code from here, and it will sync to my GitHub repo, right? And the way to do it, you can go to your user settings, and you see this option Git repo, and this is where you would select the Git provider and commit. So there is this workspace API that you can do CI/CD based on the version control system that you use. Now let's talk about this dashboard. So now you have done some analysis, and you want to share the results with the stakeholders in your company. And what you could do ahead, what you can do is you can go to View, and then say create a new dashboard. And as you see, this dashboard, you can go ahead and change the dashboard, or you can go ahead and do present. And then you get this link, and then you can basically share this link with your VP of sales, who can basically see this dashboard. And that person will log in using the Azure Active Directory authentication, so you don't have to worry about the fact that, hey, it could be shared with anyone. And if you come back here, what you see is something called widgets. So let's go ahead and come back to the workspace. And if you come back, you see this option where you can basically say, on any time a widget is changed, just run the notebook. So let's go ahead and change this widgets to say California. And then if you see the notebook is running, so it will go ahead and make changes to whatever analysis you have done. And that is just an example of how productive it is to use a workspace, to use a Databricks notebook, so that you, as a data scientist, can iterate very quickly. Now let's go back to the presentation. So before I go further, any questions? Yes? So the question is, what happens when you share a notebook and the cluster is not running? So to the person that you have shared the notebook, if the person has access control to start a cluster or restart a cluster, that person can restart the cluster and run the notebook. But if the person does not have, he or she will have to ask the admin to start the cluster to run the job. Yeah. So let's go ahead and talk about the machine learning scenarios, right? So as part of machine learning, the typical scenarios are like just some basics, like an email comes and you want to classify the email as a spam email or as your personal email or professional email, and you would end up doing classification. Or you want to do customer churn analysis, and basically you want to predict which customer is going to churn based on the usage pattern. Or you want to predict sales, or you want to do movie recommendation in like Netflix or other providers, or you want to do anomaly detection, right? So what does Spark provide as part of machine learning? So Spark, as a unified platform, which we talked about, like structured streaming, graph analysis, machine learning is yet another component. And what machine learning provides is this ML-lib, which has built-in functionality for you as a developer and data scientist to use this built-in functionality, whether it's doing linear regression or classification or decision tree or k-means or different algorithms, which are already part of the ML-lib library. And you can just go ahead and create an ML pipeline, train your model, and then do some prediction, and then operationalize it. So this has been growing at a pretty rapid rate. In fact, there could be the case where you do not have, where you have dependency on some library that you created. You can go back to the workspace and import a library from a Maven repository. So it has gone to that scale. And in fact, you can provide an option that any new cluster that is created, they can just get attached to the library that you have imported from the Maven Central, right? So as part of Azure Databricks with ML, you get all the benefits. So as we went ahead and mentioned the fact that it has interactive analysis, or you can basically have the data. So you get all of that with the fact that you don't have to manage the cluster and so on. And beyond that, you get this ML-lib capabilities. And one of the things that as a first party service that you get is the unmatched support and the SLA. So it comes with 99.95 SLA that you as a data scientist don't have to worry about making sure the service and the connectivity is up and running or not, right? So to start with, as part of the ML pipeline, you start with obtaining the raw data, and then you would split the data. So you would want to split the data into training, test data, and validation data sets. So you would train your model on, let's say, 70 or 80% of your data. And once you train it, then you want to test it and then evaluate it, right? So you would do some feature extraction, because to use any of the ML models, you want to do some cleansing of the data. You want to do some feature extraction. For example, you would end up using some transformers as part of the built-in capability, whether it's string indexer to convert it into a numeric value, or whether it's tokenizer or one-hot code encoder. And so different capabilities are available. And then you would use an algorithm to do some supervised learning or classification, and then finally you evaluate the model. So these are the typical pipeline scenarios, like you could create different models and then basically evaluate it. And you can put this into a pipeline so that you as a data scientist do not have to worry about doing this for different data set at every time. You of course have to instantiate the model, but once it is instantiated, you could use the same pipeline to do the analysis. So what is a transformer, right? As I talked about, as part of the transformer, the ML models requires the inputs to be in certain form, and so you would, let's say, you would have to use the numeric values, so you would end up using string indexer. Or let's say the numeric values do not make sense. For example, if you're associating Saturday with 6 and then Monday with 1, of course, you cannot say Saturday is greater than Monday, so you would use one-hot encoder to give some meaning to that numeric value. So, and then you would use estimator to do, which is again a transformer, and then to produce a model. And then you fit this thing in a pipeline, and then basically, to give you an example, instead of doing transformations for each individual data set, once you fit it in the pipeline, it can run automated and can come up with the best model by doing hyper tuning and stuff like that. So let's go ahead and take a look at one of the ML scenarios. So I have this power plant demo where from the UC Irvine repository, there is this public data available where I downloaded this data. And if we look at the data, it has got, so let's go ahead and look at the data. So I run this, and it has these values, which is the atmospheric temperature, the atmospheric pressure, relative humidity, the power output. And what I want to predict is these values are coming from the IoT sensors, which are basically in the power plant. And I want to predict what is going to be the power output, and based on these different values, is there a correlation of atmospheric temperature with the power output, or is there a correlation of relative humidity with the power output? So let's go ahead and do some analysis. So I come here and then try to get some stats of these data to see what is the min, what is the max, what is the standard deviation. At the end of the day, it comes to statistics. So you want to see the stats of the data. And once you see, let's go ahead and start seeing if there is any correlation between the values, right? So I run this. So the first thing I want to see is there any correlation of atmospheric temperature with the power output? And what we see here is seems to be a strong correlation of temperature with the power output, which means as the temperature is going down, the power output is increasing, right? And then I can see, just like that, I can go ahead and see if there is correlation between other columns. Right, so let's go ahead and check for exhaust vacuum. And yeah, there is some correlation, but let's see how it goes. One of the things is, as part of the notebook, when you can even go to the jobs and basically view how the jobs have been executed. So you could see the different stages, or you could see the locks on the executors and so on. So this helps you, as part of the live debugging in case any job fails, like what stage, like whether it used it in an optimized manner or not. So now I go ahead and try to run it with the atmospheric pressure, and then let's see what happens. So there is not much resemblance, but we'll see what it, and just we do with relative humidity and other parameters. So I won't go into detail on this, but basically I get an idea in terms of how my model or what my data is and if there is any correlation, right? So once I know, I want to now do feature engineering and clean my data to put into an ML model. So as part of that, I will go ahead and use this vector assembler capabilities or API. And as part of vector assembler, what I am doing is all these different features, which are the atmospheric temperature, the exhaust vacuum pressure, and the relative humidity, putting it as part of the input column and features as output column, to be so that it is in a format that my model can understand, right? So I go ahead and then I split the data into 80-20 with 20% as test set and 80% as the training data set. And then I enable caching. So typically in the ML scenarios, because you would be tuning your model, you would be training your model, and as part of that, you would end up using the same data set. So if you cache it, which is part of the in-memory RAM, the results are pretty fast, right? Then I go ahead and instantiate this linear regression model, and then basically I go ahead and I start training the model to see what is the equation that I get as part of the correlation. So we should expect an equation. It is something like y equals a plus bx1 with the different intercept and the coefficient values, right, where x are the different variables. So I go ahead and calculate the intercept, and I go ahead and calculate the coefficients, and then put this in an equation. And as part of the equation, we get this where y, which is your power output, is and if you see the equation, it's 1 minus 1.9 times the atmospheric temperature, which is similar to our observation that when the temperature is going down, the power output is increasing. So in order to, let's do some prediction and see based on this linear equation, what is our prediction compared to the actual result. So let's go ahead and do some prediction. And if we see, this is the actual value, which is 490, and the predicted value is 492. So we want to understand how much is the error rate based on our model. And that is where we will go ahead and calculate values like RMSE, things like that, and different stats. So we come here and then basically calculate those values. And what we see is the RMSE is 4.5. Now, what does that value mean, right? And typically, a model which is good, the RMSE is within 2. 98% of the RMSE is within 2. So let's go ahead and create and see whether it's within 2 or not. So I run this, and then this is the histogram chart, and let's see in the pie chart how much values it is. So if you look at this, 29 plus 68%, which is roughly like 97%, and this is within 2, which means like our model is good, right? And then now that we have done, we know that our model is good, but there is still some error value. We want to tune the model, right? We want to make sure like because the data set that we gave was 80%. Now you want to tune it by providing different parameters and see if we can get a better model. And this is where we would use the hyperparameter tuning. So I go ahead and provide the parameters where it will form multiple permutations and combinations of the metrics that comes, and then create the model. And in fact, like it will not, as a data scientist, you don't have to go for each of the data sets individually and come up with a model. Like this whole thing will do it for you as a data scientist. So I just go ahead and run this, and then it will create the model, right? And let's go ahead, the model that it has created, and see what is the RMSE value. And in this case, the RMSE is coming to, now this is going to take some time, because the reason it is taking time, it is doing, in the first iteration we did it just with one parameter and one combination. Now this guy, as part of the hyperparameter tuning, it is running jobs with multiple combinations. So if you look at just the jobs, it has created 2 jobs, and then basically this is the RMSE value that it came up with, right? And which is, yeah, 4.5, and the other one was 4.59. So there isn't much difference, which means our model is identical to the best model, right? And so let's go ahead and try decision trees or other model to see if there is other kind of correlation that we get. So I won't go into detail about running this decision tree, but let's go ahead and see, what the value that came out. So in this case, the RMSE came out to be 3.8, and I do some prediction based on this. And now you want to operationalize this, right? You have done some prediction, you have come up with a model, and now you want to operationalize this in the sense like you want to export this model and then run it as on a Spark or non-Spark platform. So if you attended yesterday's keynote, you would have seen using the API, you can deploy the exported model to a ACS cluster, and then it would predict results in real-time manner. Databricks also has this model export functionality where you would just run this model export. And so I import this model export functionality and run this, and I can actually save the model to my local drive or wherever I want to. And once I save it, then I basically can use that model to run it on other systems that I want to. So I can use REST APIs to create a web service and so on. So let's go ahead and run this. And this is going to export the model. And so I will go ahead and copy this into a DBFS location, which is the DBFS file system built. It's an extraction layer on top of the storage. And then go ahead. So right now I can see that I can go ahead and download it from this location. So let's go ahead and copy this. So I choose my region where I'm running this, and then go ahead and use the workspace ID. And see, I have got the model downloaded, so I can go ahead and then deploy it in any of the systems that I want to do for prediction. So with that, I want to give some time to talk about, yeah, so you have a question?
Yeah, whenever you're done.
Yeah, so this was about machine learning, but there is a lot to cover, so I will give time to Maddie to talk about deep learning and graph analysis. So Maddie, you can come, and if you have questions, I can answer meanwhile.
So something we're struggling with at the moment. So between Azure Databricks and ML Studio,
Yep.
There's a lot of similarities. So I know the answer that there's size limits on the data sets for Azure ML and the scale and sharing piece of that. A lot of what you've shown is possible through ML Studio as well, all the regression, training, all the ingestion, all that.
Yep.
So for my use case, I only have a few data scientists, and our data sets are small. Is there any reason why we should be considering Databricks versus ML Studio, which is what we are at the moment using?
Yeah, so the question is, you want to basically operationalize, like you have ML Studio, and there is a lot of similarity, and you want to possibly use ML Studio as part of operationalizing this ML model that you created in Azure Databricks, right? And so yesterday there was a keynote in which there was a demo. So we have this feature which is going to be coming soon. And what this will allow is that you can export a model using Python API that you created in Databricks, and that can be deployed to a ACS cluster using the ML management APIs, and then you can use the ML platform to do some prediction using that.
To wonder why I should use Databricks versus ML Studio, where I can do most of that work anyways.
I see. So the question is, why use Azure Databricks versus not use ML Studio? So Depending on your use case and your scenario, like with Azure Databricks, now it is a one unified platform where your data scientist would use like structured streaming, or would use ETL or data warehousing, or machine learning, or graph analysis, or deep learning, all in one platform. So if you want to use one single, which provides different APIs, you can just use and operationalize using that. And the fact that MLlib, the Spark that provides, which is again, and the added functionality that Databricks runtime has, you could just use that. So that is one way to look at it. But if you are dependent on certain libraries which are already part of ML, and your scenario is just ML, then you can use that. But if you see that, hey, I have to do graph analysis, I have to do deep learning, I have to do this, then let's just use one platform, and then you can, in fact, use both as part of the operationalizing thing. So you can take advantage of the rich APIs that Spark provides with Databricks, and then you can export it, and then you can just use ML Studio for productionalizing it. Thank you.
Cool. Thanks, Manu. All right. So I'm going to cover a couple of things today. As Manu mentioned, a couple of different ML techniques, their applications, the challenges that come with it, and then how does Azure Databricks, along with Apache Spark, solve some of those challenges. So how many of you have heard of deep learning? All right, a lot. Now, keep your hands up. How many of you use deep learning today? OK, a couple. Cool. So I'm just going to cover, on a high level, what is deep learning. It's a technique that is very, very suitable for identifying patterns in unstructured data. Now, think about data like images, videos, text, speech, like a lot of different unstructured formats. So that's where deep learning really shines. And it's essentially a set of like machine learning techniques that use different cascading of layers, which converts like these numerical inputs. And then output of that is essentially your trained model, right? Now, you can do any other machine learning tasks like classification, regression. Manu showed some of those earlier today. So you can use deep learning for that. But why is deep learning like so popular? Like it was available back in the 80s as neural networks. There wasn't much success back then. But right now, it's gaining popularity because things that weren't possible before are possible today. We have advanced hardware. We have these really high-power computational engines. So all this, and it's become easier and easier and more feasible today to collect and process and store massive amounts of data, which is required for something complex like deep learning. But even though all these things are available, we don't see deep learning that much. Like 2 out of 100 people here are using deep learning. There isn't enough adoption in the industry. And the reason for that is the challenges that come with it, right? First of all, you need massive amounts of compute time, resources, to be able to get a good deep learning model, a model that's well-trained. Second of all, you need immense amount of engineering hours where you need manual intervention to tweak and tune some of those parameters to make sure like you are getting a good trained model. And then finally, because deep learning is so complex, you need lots and lots and lots of data. And this data has to be labeled for the model to be able to train itself. Because essentially, if you think about it, deep learning is something that learns by itself from the data. The features and the tasks are learning directly from the data without much human intervention. So what makes this worse is some of these smaller tasks, some of these smaller issues that come with it. And that is, how do we optimize the distribution of deep learning to various other compute engines, right? And it really isn't an exact science because there's still a lot of tweaking and tuning of parameters that engineers have to do. And all the ML, or most of the ML frameworks that are out there, they're pretty like low-level APIs, and it's a pretty steep curve to go and learn those APIs and figure out what tools do I have to stitch together, because there's a lot out there today. And finally, as I mentioned earlier, it's a complex modeling system, and you need lots and lots of data. So how do we make deep learning more accessible? How do we increase the adoption so you can use deep learning to build more innovative and interesting solutions for your problems? That is something we're hoping to solve with what we call as deep learning pipelines. Now, a couple of things that you see here is we leverage the power of Spark in the Azure Databricks platform. So you're able to get the compute speeds, the scale that comes with Spark and Azure Databricks. Bhanu shared some of the auto-scaling features with you today. So we leverage that elasticity so you get immense amount of compute that's required for some complex modeling like deep learning. Second would be the MLlib API, the pipeline API that Bhanu also shared, where you can basically cascade different tasks into a pipeline, and they automatically fit and give you a model that's right for the task. And finally, this is pretty much like the core of deep learning. It's like, how do I leverage intermediate representations of my learnings and apply it to data that is similar or related? So that is essentially the core of deep learning, which is called transfer learning, where you leverage pre-trained models. And because you leverage pre-trained models, you don't have to go and get all this complex data and massive amounts of data training set to train your model, because there is a model already trained for the task that you're trying to do. And I'm going to show this in the demo in a few minutes. So now touching upon those, the smaller challenges that we are having with deep learning today, and how does Azure Databricks and Spark solve that, is the first one being distribute computations in an optimized fashion. We get that with Spark and Azure Databricks. The ML tasks are distributed very well. You saw in the demo earlier. It's not an exact science, and what do we do with that? So we have well-known model architectures that are built into the deep learning pipeline API. So you can leverage and you don't have to reinvent the wheel there. MLlib pipeline API, again, very simple. I'm going to show that in the demo. It essentially simplifies the machine learning workflows. And finally, all the complex modeling that needs the complex data and massive amounts of data and labels, something that is completely eliminated by having pre-trained models and using transfer learning. So let's dive into the demo. Okay, so one thing that's, before we jump into the demo, is the scale and the distribution of compute. There are various instance types that Azure offers today. You have the memory optimized, the compute optimized, storage optimized instances, which are relevant for different workloads. So the one instance type that is very much essential for deep learning is the GPU instances, which basically have drivers built in for the accelerated hardware that's part of the core machines. So I'm actually really excited to announce that we have support for GPUs. It's in staging right now. We're going to be GAing that pretty soon. Which means that now you can go and actually build your deep learning pipelines on Azure Databricks. All right, so what you see is, I have some deep learning clusters here. Let's start with what problem am I solving today? So the problem that I'm trying to solve is I have a CCTV footage, video footage, and again, this is open data sets from the Caviar project. So I want to take that footage and basically find if there is any suspicious activity, because perhaps someone reported a suspicious activity at an ATM machine. So this footage is about, and throughout the demo, I'll be showing you some videos. This footage is about a video footage, a security footage right by an ATM machine with people coming in and out, and how do we identify if someone waving a hand versus someone punching someone else? How do we distinguish that? And how does deep learning really help with this sort of analysis of unstructured data? And here it's videos. So the first thing that I do here is, what I've done is I've imported all the data sets into DBFS, which is the Databricks file system. It's a optimized layer built on top of Azure Blob. Okay. That shouldn't take that long. All right. Let's go check on the cluster. So my notebook connected. All right, let's try this one more time. Okay. Seems like the cluster is not responding. So let's go try attach it to a different cluster. All right, while it's doing, let's actually go through the code, and I'll explain what's going on. So here, what I do is I'm taking all the video files that are part of the open data set, and I am actually capturing every frame. So basically what I'm doing is image analysis for frame by frame. So I'm storing all my frames in this folder called CCTV frames train, because I'm going to use that as my training set. Basically here, this is the Spark deep learning pipeline, where all the training images and all the frames that I'm saving, I'm going to be reading those images and then displaying them. And finally, what I'm going to do here is actually use a deep image featurizer. Now, this is where deep learning becomes really, really simple, because what I'm doing here is using transfer learning, and which is a pre-trained model in TensorFlow, which is called Inception v3. It's a version 3 of that trained model, and it's a highly optimized trained model for image analysis. So I'm taking this trained model, and I'm using my images, the frames that I've created from the video feeds, and I'm using my transform on that frame so I can extract the right features, which then what I'm going to do is use those features in my next notebook, where I do a logistic regression model, which will do the prediction of whether a particular frame has suspicious activity or not. So let me actually restart the cluster. And if this doesn't work, I have a backup. Okay. Why don't we, while the cluster is restarting, and we can go back to it. So we talked about this. Let's see. So essentially, these are all the image files, and I wrote a little utility function called display video. And this is one of the image file that is going to be, that you see. This is basically a footage from a CCTV. There is a person, that's the ATM machine right over here. And this person is just walking in front of the TV, and that's it. We talked about how I'm extracting the frames from all the video files that I have. And every frame, I'm storing that in the DBFS directory. And this actually takes a bit because it's a lot of data. And then I'm using my Spark deep learning pipeline to read the images. It's just one API call, and it reads all the images into a data frame. And then I can display all the images using a utility function, display ML, that I've written. So output of that would be something like this, where you have like every single frame that's being displayed from. And then I use the transfer learning from Inception v3 model to transform the images. All right, so for the next part of this is actually loading the training data, right? And using the features that I extracted from the deep feature imager, using those features and joining them with the training data, I can basically try to fit a model with the regression, logistic regression, which will help me predict if a specific image had any suspicious activity. So one nifty feature that I just demonstrated, where you can actually click on each data frame, look at what the schema for that data frame is. It really helps as you iteratively build within a notebook. All right. Now, how do I actually generate predictions? So I load after I create a logistic regression model, I save it to DBFS. It's, again, another store to save my model. I load the model. I read the test data, and then I generate predictions on the model, using the model as a test data. Now, in MLlib, the model acts as a transformer itself, as Bhanu mentioned earlier. So it will transform the test data, and then I should be able to get a result if a particular image is actually a suspicious image or not. So this one, as you see, there's a person on the floor, which means something happened to this person, but this frame doesn't really give me the entirety of what actually happened. So here, I can actually go to the actual video for that frame, and I can look at the entire video footage to see what exactly happened to the person who's on the floor. So here, doesn't look like anything's going on. And there, okay, now there is a fight, and ooh. All right, knocked out. So this is, by the way, all demo, and it's not reality. So that's essentially that's kind of the power of deep learning. Unfortunately, I'm not sure what's going on with the actual demo, but I just recorded it this morning. So what I'm trying to say is, having deep learning pipeline APIs and using transfer learning, it was a matter of a few lines of code. I was able to analyze images, figure out and make predictions on those images. And this is something that's very inventive and solves problems that were unimaginable before these capabilities were available. So going back to, let's see. Can come back to this. All right. So what's the actual value, and what makes it really easy for deep learning is the deep learning transform. Essentially, if you would run this on a single node machine, it would probably take a day, a little over a day. Depends on what you're doing, sometimes weeks, number of data. But if you are running it on Apache Spark and using Azure Databricks, because of the optimizations that we have built for Azure, they actually run under 10 minutes. The second aspect is simplicity of the APIs. You saw, it's essentially one-line APIs where you read your images, where you run your transform, where you fit your models. You could use logistic regression. You could use any other modeling technique. But it essentially is a very easy-to-use API that just accelerates the development time and gets you to the results quicker. And then the final aspect is the deep embeddings, where we don't really need to label any data because we do transfer learning and we use models that are already trained with a lot of, in this case we use Inception, which is trained with a lot of image data. So the model essentially learned from that data, and then the features were extracted with it. So we don't really need to do any additional labeling of the data to be able to make predictions and so forth. So that's kind of what I had for deep learning. So the second application that I wanted to talk about, and I know we're running close to time, and I want to leave some time for questions, is graph analytics on a very high level. So I'm going to touch on some just high-level key points on graph analytics, like what is it? I mean, most of you already know, graphs are vertices and edges. But when you think in terms of, in the context of like data science, your edges or your vertices and nodes are really your objects and your entities, and then the edges are really the relationships between the objects. And if you really extrapolate in the context of data science, they tell you the dependencies, the complex dependencies that exist between data, right? And using these dependencies, that's how you arrive at different insights within the data. There's various types of graph analytics on a very high level. You have path analyses that tells you, hey, what's the shortest distance between two nodes. There is a connectivity analysis where you have to figure out, what is the strength of this relationship. Where is the weak spot in my power grid, right? That could be like one of the use cases. Centrality analysis, that mainly depends on figuring out the relevance in terms of, in my social network, who are the most influential people, or, what are the most influential brands that are being advertised in an avenue. And finally, the community detection. This is, used a lot to figure out target audience for marketing campaigns, ads, and so forth. So on a very high level, these are the type of analyses that you can do. So Apache Spark has graphics libraries, which are, it's a general purpose graph libraries. They're optimized for distributed computing, and all the, the algorithms like PageRank and connected connected components just come right out of the box. But there were a couple of challenges with GraphX, which is why we invented graph frames, which I'm going to talk more, is it really didn't have a high-level programming support. So you can only use like RDD APIs. There is no Python, Scala that you can use. And then they weren't quite designed to leverage all the optimizations that happened in the later versions of Spark. So graph frames are really built on top of data frames. I mean, if you're using Spark, you already know what data frame is. And essentially, a graph frame is a data frame that has two data frames, which is it has a vertices data frame and an edges data frame. So it's a really simple object, very easy to build. So what can you do with these graph frames, right? There's like 3 different things you can do. One is you can run just Spark SQL type of queries on your graph frames, with filters, joins, and so forth. The second aspect is about motif finding. And that really is about finding structural patterns within a graph. Now, if you look at this example, right, you have, this is essentially a, this graph represents the nodes in this graph are airports. As you can see, it's like Seattle, San Francisco, JFK. And then the edges are really the trips that have occurred between these 2 airports. Now, if I want to find a pattern, so the motive that I'm trying to find here is, the route that happened from JFK to Washington Dulles, and then Washington Dulles to DFW. So, but there is no route from DFW back to JFK. So that's this, A to B, B to C, but no C to A. So that's a pattern that I want to find in this. I mean, this is a very simple graph, but imagine like a really complex graph, and you want to find this pattern, different occurrences of this pattern within a graph. Then you can use graph frames for that, and you can assign filters. And here, essentially, the filter that I'm adding is, anywhere where there's a delay in the flight for like more than 20 minutes, hey, I want to know. And finally, the graph algorithms, where there's a lot of graph algorithms, like get me the shortest path, the most accessed web pages, which is a very popular one called PageRank. Breadth first, shortest paths between different vertices, and then you have connected groups, like trying to find the cohorts and the groups within a graph that you can basically make sense out of. And then finally, we've made really easy to write and read graphs. So essentially, they're like data frames. They support all the formats that data frames support, Parquet, JSON, CSV, and so forth. So it becomes really easy with, you can see the API is just read and write API, just like data frames, and you can save and load your graphs. So I'll do a quick demo. Let's see. So here, essentially, I am, this is a Scala notebook, but I can write SQL in here. I am creating all my data. It's an open data set from Department of Transportation. So let's just, and one nifty feature in Databricks is also like you can just run a lot of cells all at once. So if I do run all above, it's going to go and run like all the cells above the cell. And it just shows you a notification on where the command is, where the cursor is, and seems like it's at cell 14, so we should be done pretty soon. All right, now let's go build a graph. I can visually, and so once the graph frame is ready, so let me actually show you. So this is the graph frame created with trip vertices and trip edges, which are essentially data frames. And once my graph frame is ready, I can do all sorts of analysis, just SQL type analysis on this, right? Like here I'm doing, hey, what are the number of airports that I have? How many number of trips were taken between these airports? And then, it's basically sending a Spark command to the cluster, and it's like, okay, 279 airports, and hopefully it'll tell me how many trips there were. So it's about 1.3 million trips. I can visualize this data. Let's like, oops. No. So it's doing a command. This essentially is a D3 visualization. So, as Banu mentioned, you can do custom visualization with D3, Plotly, Bouquet, like other third-party libraries, but there's also built-in visualization in notebooks. Here, I wanted to do something fancy and advanced, so I chose to do D3. So this kind of gives me a visual representation of, where, like, what do the connections look like? So the bigger the bubble, the more the connections, right? And so you can like do a lot of querying. From a motive standpoint, it's just a simple, you can do a find command on your graph frame and specify the motive or the pattern that you're trying to look for. And here I'm basically looking for, hey, what are the different trips that are getting delayed at SFO? And so I'm adding a filter about delay, which is greater than 500 minutes between both connections. And if I run this motive, and try to display it, it will actually show me all the trips with probability of, So it's actually showing me, OK, so this is a trip, S. So this is the source, which is Honolulu. And this is the edge of where it's going to. So the destination is San Francisco. And from San Francisco, it then goes to Miami. So this is like my entire trip of motive. So now I'm able to actually visualize my patterns, and then I can, you can just take this data and do further analysis. And then finally, we talked about out-of-the-box algorithms that are available as part of GraphX, and as well as graph frames. So graph frames is, you can think of like a wrapper on top of GraphX, and you can use these algorithms. And here I'm showing the PageRank algorithm. So you can essentially have vertices, and it's really graphframes.pagerank. Like, it's a very simple API, and there's other algorithms that you can use similarly. So let's just run this. And this will, display like all the airports that we consider are the most accessed airports, and hence, the most important airports. So this is doing a Spark job. OK. All right, so that's essentially graph frames. And I think we're ready to take some questions. Yes.
I'm a developer, I'm not a data scientist, but I'm curious how are these things tested?
How are these things tested? Yeah, so one of the ways we do it is we have REST APIs for everything pretty much you see in the UI. And we have documentations, and there's a slide on it. So the way customers test it is they use the REST APIs and build out, say, a Jenkins pipeline to do end-to-end testing. So jobs is another way where you can test, because this is a notebook, and you can set the notebook as a job. So this is something Banu showed earlier, right? And as part of setting this as a job, it's really a one-click, and then I can just go and run now. And there's APIs to do this as well.
Any last questions?
Thank you.
Thank you, everyone, for coming. I hope this was useful. Thank you.